Hmm? Greetings, students. Here we are going to talk about problems on random process. Random process means real random variable with the time t. Random variable with the time t is called random process. Here, random process denoted as capital X of t or x of t. Here, this is capital X of t or small letter x of t, but the t should be small letter. It is denoted as time. So x of t is a random process. Here, whose probability value is p of x of t equal to n. This is equal to at whole power n minus 1 divided by 1 plus at whole power n plus 1 if n equal to 1, 2, 3 and so on terms. Suppose n equal to 0, function p of x of t equal to n equal to at divided by 1 plus at. So here p of x of t equal to n is two splitter terms. One is n equal to 0, so that one function exists. Another one is n equal to 1, 2, 3 and so on terms. Another one function is exist. Here this is a given terms. So we are going to prove x of t random process is not a stationary process. We are going to prove x of t is not stationary. So random process means random variable with the time t is random process. This random process is sometimes stationary or it is not stationary, but here we must show that x of t is not stationary. So stationary means a random process. Each and every statistical values we have to find, it should be a constant. Then only this x of t random process is stationary. Suppose it may be with the time t, we can say that x of t random process is not stationary. That means expectation of x of t and variance of x of t, standard deviation of x of t are find out here. We get the result is with the time t is not stationary. Suppose mean, variance, standard deviation, we get the result constant is stationary. So here the probability distribution is given because x is a random variable with the time t is considered as x of t. We put here x of t as small letter n because n is a number. So we can put here 0, 1, 2, 3 and so on. Here n is countable value. So n is countable, we can say that x is a discrete random variable with the time t, so that here random process is x of t is a discrete random variable. Here p of n of t, that means p of x of t, p of x of t equal to n. It consider as here p n of t. So suppose n equal to 0, we substitute the given substitute the given problem. Given is n equal to, suppose given is n equal to 0, n equal to 0, the function is 80 divided by 1 plus 80. So that here we write n equal to 0 means p of x of t, probability of that value p of 0 means 80 divided by 1 plus 80. Suppose n equal to 1 means we refer the given term n equal to 1 comma 2 comma 3 and so on. So that function is 80 whole power n minus 1 divided by 1 plus 80 whole power n plus 1. So put n equal to 1, we get probability value is 1 divided by 1 plus 80 whole square. Suppose we put to 2, we get 80 divided by 1 plus 80 whole cube, like that. So we are going to verify x of t random process is not stationary. So we find mean equal to expectation of x of t. Here we can write the basic formula mean equal to expectation of x. Expectation of x equal to summation x into p of x. It exists if x is discrete random variable. Here n is a countably infinite number. So here x is a discrete random variable, so that we use to find the mean equal to expectation of x of t equal to summation. The starting value is 0 to infinity and n into Pn of t, or we can write this term expectation of x of t equal to summation n equal to 0 to infinity x of t into P of x of t. Already we know that x of t is n. We consider summation n equal to 0 to infinity n into P of n. After that we can expand this summation. So summation n equal to 0 to infinity n P of n value is at whole power n minus 1 divided by 1 plus at whole power n plus 1. So expand the summation, put n equal to 0, the full term is 0. So suppose n equal to 1, we get n so equal to 1. So 1 into at whole power 1 minus 1. 1 minus 1. At whole power 1 minus 1 divided by 1 plus at whole power 1 plus 1. So that we get at whole power 0. At whole power 0 means anything power 0 is 1. So that we get this 1 divided by the denominator 1 plus at whole power 1 plus 1 is 2. Similarly, we substitute n equal to 2. So we get at whole power 2 minus 1, 2 divided by 1 plus at whole power 2 plus 1. So we get 2 minus 1, at whole power 2 minus 1 is power 1. We can write at. So 2 into at divided by 1 plus at whole power 3. Like this. So this term equal to, here each and every term has 1 divided by 1 plus at the whole square is a common term. So we can take outside from this 1 divided by 1 plus at whole square. So the remaining value is 1 plus 2 into at divided by 1 plus at plus 3 into at divided by 1 plus at the whole square plus and so on terms. So this term is like that 1 minus alpha whole power minus 2. 1 minus alpha whole power minus 2. This is based on 1 plus 2 alpha plus 3 alpha square, 1 plus 2 alpha plus 3 alpha square plus and so on. It can be written as 1 minus alpha whole power minus 2. Here alpha consider as at divided by 1 plus at, so that the term equal to 1 divided by 1 plus at the whole square into 1 minus at divided by 1 plus at whole power minus 2. So we can multiply cross with 1, the denominator term, we get 1 plus at minus at whole divided by 1 plus at. So plus at and minus at get cancelled. So we get 1 divided by 1 plus at whole power 2 into 1 divided by 1 plus at whole power minus 2. So minus 2 can be written as reciprocal multiplication term. So we get 1 plus at whole power 2. So cancel this numerator term and denominator term. The expectation of x of t equal to 1. The expectation of x of t is a constant. So we have to find the expectation of x square of t. So using the formula summation x square of t p of x of t. It is based on summation x square into p of x. This is expectation of x square. Generally, expectation of x square equal to summation x square into p of x if x is discrete random variable. Similarly, here x of t is the random process, so that we can write the expectation of x square of t equal to summation n equal to 0 to infinity x square of t p of t or p of x of t. So this term is considered as summation n equal to 0 to infinity n square into Pn of t. So this term equal to summation n equal to 0 to infinity n square into Pn of t. Here Pn of t or P of x of t is at whole power n minus 1 divided by 1 plus at whole power n plus 1. This is given. So substitute in this place P of x of t, and we can add and subtract the term n to identify the formula easily, and easily simplification do. So we can add here n and subtract n. So this term is n square plus n minus 1. Taking out outside of the n is n into n plus 1 minus n into at whole power n minus 1 divided by 1 plus at whole power n plus 1. We consider this term equal to summation n equal to 0 to infinity n into n plus 1. This is for our convenient term into at whole power n minus 1 divided by 1 plus at whole power n minus 1 minus the separate value minus n into summation n equal to 0 to infinity at whole power n minus 1 divided by 1 plus at whole power n plus 1. So substitute the summation or expand the summation, we get expand the summation, we get, suppose n equal to 0 and n equal to 1, n equal to 2, n equal to 3, we get 1 into 2 because n into n plus 1. This is 1 into 2. Suppose n equal to 2, we get 2 into 2 plus 1. This is 1 into 2 into 3. So these values are based on this format. So 1 into 2 into 1 by 1 plus 80 the whole square plus 2 into 3 into 80 divided by 1 plus 80 the whole cube plus and so on term minus expression of x of t. So this term is considered 2 by 1 plus 80 the whole square is common. So taking outside, so the remaining term is 1 plus 3 into 80 divided by 1 plus 80 plus 6 into 80 the whole square divided by 1 plus 80 plus and so on terms minus expectation of x of t value is 1 already found. So this term equal to 2 divided by 1 plus 80 the whole square into 1 plus 3 alpha plus 6 alpha square plus and so on minus 1 because alpha equal to 80 divided by 1 plus 80. So this is based on 1 minus x whole power minus 3. So 1 minus x whole power minus 3 equal to 1 plus 3x plus 6x square plus and so on terms. So that we can write 2 divided by 1 plus 80 the whole square into 1 minus of 80 divided by 1 plus 80 whole power minus 3 minus 1. So simplifying, we get 1 plus 80 minus 80 whole divided by 1 plus 80. So 80 and minus 80 cancel. So we get 2 divided by 1 plus 80 the whole square into 1 plus 80 the whole cube minus 1. So denominator term is power 2, numerator is power 3. So get cancel. So this term equal to 2 into 1 plus 80 minus 1. This term equal to 2 plus 280 minus 1. That is equal to 1 plus 280. That is the expectation of x square of t equal to 1 plus 280. It is depend on t. So we have to find the variance of x of t based on the variance of x formula. Variance of x equal to expectation of x square minus expectation of x the whole square if x is a random variable. Here x of t is a random process, so that we can write here variance of x of t equal to expectation of x square of t minus expectation of x of t the whole square. Already we have to find the values. 1 plus 280 is expectation of x square of t, and expectation of x of t value is 1, the whole square is also 1. So 1 plus 280 minus 1 is 280. Here variance of x of t is depend on t, so which is not a constant. So we get here x of t is a not stationary. Suppose a statistical term variance of x, expression of x all are get standard deviation. Like these terms are get constant, we can say x of t is a random process. X of t is a stationary. But here variance of x of t is 280. So it is depends on t, so that we can say given x of t random process is not a stationary process. Variance of x of t equal to 280. This is depends on t, so that we can say given x of t random process is not a stationary. Thank you.